Hello everyone, how are you? I am Ghaida, student at Faculty of Engineering. Today we're gonna talk about low-level programming language and differences between it and high-level programming language. Low-level programming language, known as the computer's native language, are very close to writing actual machine instructions, deal with the components and limitations of computers, control the optional semantics of the computer, and provide abstractions or no abstractions at all. Let's start with benefit of low-level programming language. Number 1. Programs developed using low-level language are fast and more efficient. Number 2. Programmers can make better use of the processors and memory. There is no need for any compiler or interpreter or to translate the source to machine code, this shortening the translation and interpretation time. Number 3. Provides direct processing of computer registers and storage. It can communicate directly with hardware. Number 4. It is used to write programs that related to the specific architecture and hardware of particular type of computer. But it is closer to native language of the computer, which makes it more difficult for programmers to understand. Okay, let's talk about low-level programming language sections. Okay, first generation low-level language, the first generation of a programming language in general. So it is called 1GL, is considered one of the machine languages. Here the commands are written in the form of a string of binary numbers 0 and 1, so that the computer can understand them directly. They perform very simple operation and deal directly with what is stored in the device's main memory. First generation language is considered the only language that the microprocessor can process directly without the need to conversion. Machine language is not used directly at the present time because it requires doing many details that the high-level language does automatically. Second generation low-level programming language. The second generation of low-level programming language is known as 2GL, which is called assembly language. The commands are written as abbreviations in English, which are easy to understand, and the assembly language is translated into machine language, and the assembly language deals directly with the internal components of the computer. With simple instruction directly into machine language with easy, although assembly language is not specific to the microprocessor in particular, it is considered one of the second generation languages. We talked about low-level language. Let's talk about high-level language. Okay, what are high-level languages? A high-level language is a third generation language or 3GL, such as C and C++, Java, JavaScript, Visual Basic, Fortran, or Pascal, that enable a programmer to write programs that are somewhat independent of a particular type of a computer. These languages are considered high level because they are closer to human language and farther away from machine languages. It is more problem-oriented than machine-oriented. There are many high-level languages, and the high-level language you choose depends on the type of a problem you are trying to solve in general. High-level languages are classified into three types. Number 1, imperative language. Number 2, declarative language. And number 3, object-oriented languages. Low-level programming languages and the difference between them and high-level language. Low-level programming languages, known as the computer's native language, are very close to writing actual machine instructions, deal with the components and limitations of a computer's control the operational semantic of the computer, and provide abstractions or no abstractions at all. What is the basic differences between high-level language and low-level languages? It is easily interpreted and compiled as compared to low-level language. It can be considered as a programmer-friendly language. It is easily to understand, it is easy to debug, it simply to maintain. It requires machine code compiler. It can be run on different platforms. It can be ported from one place to another. It is less memory efficient. Must notice that low-level language, also known as machine-level language. Low-level opposite high-level. It is easily understood by machines. It is considered a machine-friendly language. It is difficult to understand. It is difficult to debug. It is also complex to manage. It cannot run on different platforms. It requires an assembler to translate the instructions. It is not widely used in times. From the above, we conclude that the basic differences between high-level and low-level programming language is that the low-level language is far from humans and provides the faculties for writing programs at the hardware level, while the high-level language is close to humans and does not provide the possibilities of writing a program at the hardware level. But the question is, why do we use low-level language? Low-level language differ from high-level language in several ways. Programs written in a low-level language can directly access to general-purpose registers in processors to store and retrieve data. They are potentially more efficient than those written in high-level language because the programmer can control the exact instructions that the processor executes. They are written in a specific instruction set, so we cannot be transferred between different processors. In addition to many other important advantages, the programmer is able to ensure that the machine code is its most efficient from assembly language. Programs are also suitable from systems and device drivers with low memory. As we mentioned earlier, low-level programming languages are languages that are close to machine code and offer direct control over hardware and memory. Examples include machine language. This is the language that the CPU understands directly, consisting of the binary code zeros and ones. And assembly language uses symbolic representation instead of binary to represent machine instruction. Assembly language needs to be converted into machine code by an assembler. There an example in assembly language. Assemble instructions to add two numbers in an 86 processors may look like this. Okay, this is the code in assembly language. This would translate into binary instructions, machine code that the processor executes. And here is a simple example in assembly language for Linux, which exists the program with a status of code of 0, successful exit. This is minimal program that simply exists without doing anything else. It's a good starting point for understanding basic system calls in Linux assembly. And here a simple hello world program in assembly language for Linux that uses a system call to print the message to the console. In this point, we're gonna take a simple example of adding two numbers in both Python and assembly language. Okay, this is Python example. This is the code. I will explanation it. Okay, number one, function definition def, add numbers a and b defines, function that takes two parameter a and b. Number two, addition, return a plus b, return the sum of a and b. 3. Calling the function result, add number 5, 3, calls the function with 5 and 3 as arguments. Number 4, printing the result, print the result, print the result to the console. Okay, this is a simple example. This is the code. Okay, the explanation of assembly code. Number 1, section text, the section where the executable code is located. Number 2, global start, defines the entry point of the program. Number 3, initializing numbers, move RAX5 stores the first number 5 in RAX restriction. Move RPX3 stores the second number 3 in the RPX registers. Number 4, addition, add RAX. RPX adds the value in RPX to the value in RAX, storing the results in RAX. Number 5, printing the result. The code includes number 4, addition, add RAX. RBX adds the value in RBX to the value in RAX, storing the result in RAX. Number 5, printing the result. The code includes a placeholder to print the result. Implementing this would require more instructions for converting the integer to string and using system calls to print it. Number 6, exiting the program. Move RAX 60, load the system call comp number for exit, X or R, RDI sets the exit status of 0, syscall execute the system call. Okay, let's comparison from the two examples. Python easier to read and write. It abstracts away low-level details like memory management and system calls. But assembly requires more lines of code and is more complex. It directly manipulates hardware and user registers, which provides more control but is less innovation. To run the assembly code, you would need to complete the printer number function and follow similar steps for assembling and executing it as shown in previous examples.